Okay, so I'm going to start talking. I think, unfortunately, my co-host is still unable to talk. But hi, I'm Eli. I'm one of the hosts for this live solve, and theoretically, we'll have some other people talking, not just me. So that might happen soon. Yeah. Uh, what's going on? How's your day been? Go ahead. You can't hear me. Ah, one second.
Okay, cool. Hi, everyone. Great to
Yeah,
be here with you guys today. Sorry for some technical issues with the video and sound and stuff.
yeah, and I'm not even sure if people can hear us now. We may have to mute the music. Uh, I'm not sure if I should do that or not. Anyway, eventually we will have other people joining us, but for now it's me and Cynthia. So hello, and we have a representative from Math Kangaroo who will be talking, and hopefully Professor Loh will be talking as well. Uh, but I'm not sure where either of those people are. So okay, so if we don't have anything else to talk about, let's just do an icebreaker. Okay, so how about would you rather fly or teleport? Just start talking about it, you know? Uh,
Yeah.
so okay, well, I'm sending some messages. Cynthia, would you rather fly or teleport?
Ooh, that's a good question. I feel like they're kind of similar because both will like let you get to some place really quickly. But I think flying would just be a little bit more fun, you know? So yeah, I would choose flying. How about you, Eli?
Good question. I would have to go with flying as well. Although I must say it's really dependent on your definition. Because if you're flying like at light speed, then you're basically teleporting. Okay, I think we have Professor Lowe with us, and so I'll kick it
Hi.
off to him.
Oh, thank you so much. Thank you so much, Eli. And so it's great to be here. I just want to, yeah, thanks very much, Eli. I just wanted to say, I'm sorry, I joined the wrong meeting the first time, and that's my own fault. So, but it's very, very nice to be here. And I just want to welcome all of you for coming to our show. We are very happy to collaborate with Math Kangaroo officially because, well, they make great problems. Actually, I even now submit questions to Math Kangaroo. So I think it's a great source. Every time I find something particularly creative, I'll go and send it that way. But we like them because, well, the questions don't always involve a ton of calculation. They just involve a ton of thinking. And today we're going to see a ton of thinking because Eli and Cynthia are going to lead this live solve. But first, I want to also welcome a representative from Math Kangaroo to the stage, and she'll say a little bit to represent Math Kangaroo because we're very happy to work with them. Just as introduction, Xin Zhao is a center manager, and she's a resident of Blacksburg, Virginia, and has been involved with Math Kangaroo for over 10 years, beginning as a center manager. She does math. She works as a biostatistician and clinical research, and she has two kids in middle and high school, and they participated in Math Kangaroo since first grade. I actually recommend to all people with young kids. This is a great contest for young kids. And so she brings both professional and personal passion to this program. Sin, would you like to make a few comments? I'll pass it off to you.
Thanks, Professor Law.
Great. Bye bye.
Really nice meeting you. Um, hi, good evening, everyone. My name is Xin Zhao, and I'm joining you today from Blacksburg, Virginia. It's truly a pleasure to be here with math lovers and supporters. By profession, as Dr. Low just mentioned, I am a biostatistician working in clinical research. So numbers and problem solving here have always been a big part of my life. I'm also a mom of two wonderful kids, and that's where my personal connection to Math Kangaroo truly began. My children began participating in first grade, And since then, I started as a center manager and have been involved with the program for over 10 years. And my children, they quickly became a tradition. They look forward to each year joining Math Kangaroo competition. Even now in middle school and high school, they're still enthusiastic about it. It's been a fun and meaningful part of our family's journey in more than that, I have been continually inspired by the many children I have had the privilege to work with. The light in their eyes when they engage with math is truly something special. For those who may be new to it, Math Kangaroo is an international math competition that involves over 6 million students across more than 100 countries each year. Here in the US alone, more than 53,000 students participated last season at over 1,000 centers nationwide. What makes Math Kangaroo so special is that it welcomes all students from K to 12. The problems are logic-based, creative, and most importantly, fun. The goal isn't just to get the right answer, it's to inspire a true love for problem solving. I'm excited to share that registration for the 2026 competition is now open. Signing up is easy. Just visit mathkangaroo.org. And if you don't see a public center near you, I really encourage you to consider starting one in your community. I am posting a sample invitation letter to the school along with our contact information here in the chat. In addition to the annual competition, one especially exciting opportunity is our live solve sessions developed in partnership with the well-respected mathematician and educator, Professor Po-Shen Loh. Professor Loh brings incredible energy, creativity, and inspiration to these interactive game-like sessions, making math feel like a team sport and truly fun to learn. Thank you so much for being here today. Let's continue working together to help more kids discover just how exciting and empowering math can be. Thank you.
All right. Thank you so much, Sheen, for that awesome introduction to what Math Kangaroo is all about. And now I think we'll get into solving some problems. First of all, we should introduce who's talking to you. So, hi, I'm Eli, and first I'll introduce the person that I'll be working with today. Cynthia Tian is a two-time AIME qualifier, attended Promise over the summer, is also an MIT Primes Circle Scholar, so really awesome mathematician. And outside of math, she also enjoys violin and swimming. So I hope you are all excited to work with Cynthia today.
Thank you, Eli. And I guess I'll introduce you now. So this is Eli Gold. He's currently a freshman at Princeton, and he really loves pure mathematics, especially number theory. He also loves music. He does some percussion work. He loves playing marimba, and he also likes Rubik's cubing, playing ping pong, tap dancing, and playing chess. So lots of fun hobbies.
Yes, thank you so much, Cynthia. And one of those hobbies, of course, is doing math. So let's do some math today. Our first problem is the grades 3 and 4 problem number 8. And it's from the 2025 contest. And it says, which pinwheel can Jorge build with these 3 rods? Okay, so I think this is going to be like a sort of just going through all the options and seeing what works. If we just look at the first option, we see that like these 2 parts here, they don't really line up with anything that we have over here because these triangles are going in opposite directions. So I think we can eliminate option A there. Then let's look at option B. Again, we have these pinwheels that are going in opposite directions. And so I think that, again, is going to be a problem. See, option C, we have, okay, let's see, triangle and square, but they're going in opposite directions again. So unfortunately, I think option C is also out of the question. Okay, let's see. Looks like D also has these opposite triangles, and that's not one of our options, so we can get rid of D. And then finally, we're just left with E. And so hopefully it works. Otherwise, we've made a mistake. But I see that these 2 here are 2 triangles going in the same direction. So that comes from this thing over here. So that's nice. That works. Over here, we have the square and the triangle, and they're going in the same direction. So that comes from this, and that also works. And then the last thing is the 2 squares that are going in opposite directions over here. And that looks like it works as well because it comes from that. And so We have option E. Looks like it works. Is it correct though? Let's go see. Looks like we are. Okay. E is correct. And that's our first problem for today. It's a quick one. How about on to you, Cynthia? You want to take us to our next problem?
Yeah, of course. So our second one has which of the two which two of the pieces shown complete the chessboard? The pieces can be rotated but cannot be flipped. Okay, so I see this chessboard down here, and we have a bunch of these pieces, but I think the easiest way to start is probably just to draw out the the ones that fit in, right? Because we can pretty much tell based on the pattern of the chessboard. So we know that a chessboard has alternating black and white squares, and we see, so this is this missing piece right here, and we see that the top piece is surrounded by two black ones, which means that this middle one is not going to be shaded. And then this bottom one, so we can just keep alternating this way, right? So if this top one is not shaded, then the one diagonally down from it is also not shaded, and the one right under it should be shaded. And then this one over here is not shaded. The one right below the non-shaded one should be shaded. And this is a little bit confusing to see because our colors are a little bit swapped. So I'm going to start shading these with a darker color. And let's just see if any of these match what we've drawn right here. So I see that there's this first piece, and this is giving me a non-shaded top piece. These two that we haven't shaded on the sides here are also not shaded. And then this middle one and the bottom corner are both dark. So that looks like the piece that we're missing. So I'm going to circle this really quickly. But yeah, let's go through the other pieces. So obviously the second one doesn't match the one we have here because it's not the right shape. This third one, I noticed the top one is dark, but we don't want a dark top piece, so that doesn't work. This next one, the top one is also unshaded, and the two side ones are unshaded. And we have this middle one, and then the bottom one is actually on the other side instead of the side that we want it to be. So this one also doesn't work. And then the last one is a different shape. So we can be pretty sure that number one is going to be one of the pieces that we want. Now let's look at the other piece. So we have this kind of strange looking shape here, and we can draw the boxes like this. So I noticed that this piece and this piece are dark, which means the one that's adjacent to both of them has to be shaded. Or it has to be unshaded, sorry. I'll color these in white so that it's clear. And then this one over here has to be dark. The one under it is dark. The one under that should be white. And then this piece at the end should be dark. And let's see if any of these match that. So the only two that have the same shape as this are number 2 and number 5. But I see that these two end pieces that stick out on each side of number 2 are both white, but we want them to both be dark. And that's true for number 5. So the two pieces that we're missing here are number 1 and number 5. And that's answer choice B. I think I see a lot of people putting B's in the chat, so I'm pretty confident about this. But let's see if our answer is right. And yes, it is the pieces 1 and 5. Now I'll hand it over to Eli for problem 3.
Yeah, thank you so much, Cynthia. And looks like everyone in the chat was right. There's a lot of B's in the chat. That's a lot of B's. Yeah. And so the B's are buzzing, and they're all buzzing right. Okay. Now we're on to question number 16 from grades 3 and 4 of the 2025 contest. Bob makes a square from 4 rectangular pieces, and 3 of the pieces are shown. What is that fourth piece? Some deductive reasoning we have to use. I think there's a few ways of doing this. You could try to actually build the square, but I think maybe the easiest thing is just to think like how many squares do we need? Because over here we have, let's see, this first thing has 8, then this one has 4, 5, this would be 10, and then the last one over here has 6, right? Because this one is 2 by 4, 2 by 10, and 6 by 1. So we have 18 plus 6, that would be 24 in all. Okay, so if we're trying to get to a perfect square, well, we could add 1, and then we get to 25. But none of my answers look like, 1, one singular square. And also that wouldn't make sense because we have a 6 thing across here. So it definitely can't be a 5 by 5 square that we're making. And the nearest possible thing would be a 6 by 6. So we would have 6 squared, which is 36. And so if we're trying to make something that's 36 little squares in area, well, we already have 24, which means that the amount that we'll actually need is 36 minus 24, or 12. And so we can just go through the options and see, well, maybe there's multiple, but maybe there's only one that has 12. Okay, so the first one is 3 by 5. 3 times 5 is 15. That's not 12. The second one, okay, that's a lot less than 12. So that's only 5. C is 2 by 3, which is 6. That's not 12. This one is 1, 2, 3, 4, 5, 6. Okay, so 2 by 6, that is 12. So this is a possibility. And then E is 3 by 4. So that's also a possibility. Okay, but the kind of idea of doing all of this is that at least we're going to break this down, and we know that we're trying to get a 6 by 6 square. So now we can actually start building the square. Okay, so we have something that's 6 across here. The only way that that could ever do anything is if it was just on an end. So say the 6 across thing is there. Then we have something that's 2 by 5 and 2 by 4. So those definitely can't be like connected this way. So they have to be connected the other way, which means that we have something like 2 by 5 down here. Maybe it's not actually down there, but could be. So this is the 1 by 6. This is 5 and 2 up here. And then finally, we have, let's see, this has to be 4 across up here. So this would be something like this. The 2 is there. So this is 2 by 4. You know what I mean. Okay, so there's the 1 by 6, the 2 by 5, and the 2 by 4. And then that just leaves a little bit of space over here. So this is then a 3 by 4. Hopefully that makes some sense. Okay, so if we have a 3 by 4 up here, that looks like E is going to do the job. And so looks like D is out of here. And we're left with question or part E, answer choice E as our answer. I think a lot of people are saying that in the chat. Shankirth is even saying specifically it can't possibly be D. Maybe there's an easier way of seeing that, but just making the square, I think, helps us see that the answer is E. So are we correct? Is it actually E? Hey, looks like it is. Cool. Back to you, Cynthia.
Awesome. Nice job with that one. Okay, so our next problem is identical balls have been placed in 5 identical test tubes as shown. Then water is added to each of these test tubes. The water level in test tubes 1, 2, and 3 is the same, and the water level in test tubes 4 and 5 is also the same and twice as high as in the first 3 test tubes. Then all the balls are removed. Which test tube has the least water? All right, so immediately looking at this, I see that the water level in test tubes 4 and 5 is twice the level of 1, 2, and 3. So I'm going to say that these two are probably not the answer for the tube with the least water. So I'm just looking at 1, 2, 3 right now. And we remember that each of these balls takes a little bit of space inside the test tube, right? So it's going to displace some of that water. So whichever test tube has the most balls, out of these three, since they all have the same level of water, will have the least water once the balls are taken out. So it's going to be test tube 3 because that has 3 balls, and that's answer choice C. And I see a lot of people are in agreement with that. Let's see if we're right. And yeah, it is answer choice C. Okay, Eli, back to you.
Yeah, awesome job on that. Part C there. I can see that you got the right answer. And so let's move on to question number 2 from grades 5 and 6. So we're moving up a level. Last time it was grades 3 and 4, but now we've just graduated. It's amazing. Okay, so Anna has built a wall. Wow, nice job, Anna. It says 2025 on it. And now Bella is standing on the other side of that wall. So clearly there's some feud between Anna and Bella, like they're on opposite sides of this wall. I mean, I guess Anna just really wanted to separate herself from Bella. Okay, I'm not sure what the feud is about, but it's okay. We know that this wall says 2025, and we want to know, what does Bella see on the opposite side? This is cool because it's kind of like living in a mirrored universe. And so we're going to kind of see what the mirror sees. Yeah. Um, okay, so I think the way to do this is just like kind of imagine it in your head. So, Bella is on the opposite side of this wall. She's like in the screen and she's looking back this way. So her left is our right. So whatever Bella sees on the left is going to be what we see on the right here. And so we're actually going to start with this 5, but we're not going to draw a 5. We're going to start on the right of the 5 and go left, and then go down, and then go left, and then go down, and then go right. You see that that's the reflection of the 5 in the mirrored universe. Okay, and now when we get to the 2, now we're starting on the right here. So this is going to be okay, wait, I gotta not be confused. Okay, so we have to start on the right, which means we're starting on the left and going to the right. And then it's like this, and then here, and then here and here. Okay, 2, 5, cool, that's looking good. 0, I think, is symmetric, so it'll just stay 0. And then finally, the last one, well, we just figured out that the 2 basically becomes a 5, so we get something like this. And so 2505 is what Bella sees. And let's see, that looks like option B to me. And I think a lot of people in the chat are again saying B. Well, there's some D's, but I think B is the winner here. So we can see that actually it's kind of cool in general. Like whenever we have a mirror and we show a mirror a 5, the mirror sees a 2 and vice versa. So we've turned 2025 into 2505. And that's B to me. Let's see, is B our correct answer? Yeah, it is. Cool. So apparently Bella is just living in the future. What can I say? Back to you, Cynthia.
Awesome. Yeah, I'm not sure if you guys took this test online or on paper, but maybe if it was on paper, you could try and like turn over the page and like look through the back of the page. Maybe that's a hack. Um, but yeah, so our next problem, a cube is decorated by gluing identical gray squares on it. All the faces of the cube look the same. How many gray squares are there in total? Okay, so when I see this problem, the first thing I see is all the faces of the cube look the same, which means if I just focus on one face, I can multiply this by 6, as there are 6 faces in a cube, and I should get the right answer. Also, I noticed that 14 is not a multiple of 6, and 16 is not a multiple of 6, so those are probably not going to be our answers. So I'm just going to focus on this front face right here. And I see that there's one full gray square right in the middle here. And then there's these 4 half squares, and those will add up to 2 full squares. So each face has 3, and we have 6 faces. So that gives us 18 gray squares in total. And yeah, I see a lot of agreement for B. So hopefully we're right. And yep, there we go. All right, nice job. And back to you, Eli.
Yeah, awesome job. And okay, so before the previous question was like where it was a good idea to try to visualize things. I think in that case, it was actually a good idea to try not to visualize the whole square or the whole cube and just look at a single face. And then you can use some very clever reasoning since they all look the same. You can just multiply by 6. So yeah, clearly there's some different methods for different types of problems. Sometimes visualization is good. Sometimes it just makes things really confusing. Let's see which is the case for this problem. Okay, container A holds 10 liters of water. Okay, 10 liters, cool. All 5 plugs at the bottom of container A, 5 plugs, are taken out at the same time. Okay, so water is going to start flowing down. What volume of water flows into container B? Okay, container B, it's hard to see with the chat, but it's this container on the bottom here. And so the question is, oh, wow, this is actually kind of strange. How much gets into B? So I think this is just kind of using some proportional reasoning. We started with 10 liters, which means 2 liters are going to go down each of these. So each of these, we can just like put a 2. And okay, so these 2 liters are going straight down into B. So we already get 2 from here. That much we know. But then it starts getting a little bit weird. So here we have 6, right? Because this 2 plus 2 plus 2 means we have 6 in this container. And now half of that is going to drain down here, and half of it is going to go into container B. So I think that just means we're going to split it up like 3 and 3. So 3 and 3. And now 3 plus 2, I believe, makes 5. And so if my reasoning is correct here, this container B would have 5 liters in it. I see a lot of people saying option C, which corresponds to that answer. And so let's see if it is the right answer. Hey, it is. Cool. Back to you, Cynthia.
Awesome. I'm loving all these puns for the answer choices. So now, hopefully you guys are hungry. We're looking at a menu of my favorite burger restaurant, and it's written on this board. However, the rain has washed away some of the numbers. The burgers are in order by price. Which of the following is the price of one of my burgers? All right, so this top one is $3.70. The bottom is $6.80. So we can see that this is going from least expensive to most expensive. And we want to just make sure that as we're going down, we don't surpass this bottom one, right? Because the only way that it doesn't work is if the double costs more than the deluxe as we're going down it, and then that's going to mean that it's not in order of price. So let's just keep going down and trying to minimize each one while making sure that it's still greater than the previous one. So I see the first one is $3.70. The classic is going to end in 30 cents, and the least that we can make that is $4.30, right? And then the hot bacon ends in 60 cents. And 60 cents is more than 30 cents, so we can just make that $4.60. Now going down, 50 cents is less than 60 cents, so we're going to have to add a dollar and then take away that 10 cents. And that gives us $5.50. And then the next one, again, 10 cents is less than 50, so we're going to add a dollar and then take away the cents. So this is going to be $6.10. And then perfectly it works out that the next one is $6.80, which is exactly a little bit greater than the double. And now what they're asking is which one is a price of one of my burgers. So $4.10 is not in there. $5.50 is in there. $5.60 is not. 6.30 is also not, and 6.60 is also not. So we've narrowed this down to just B, and lots of agreement in the chat. So let's check just to be sure. And yeah, it is answer choice B. All right, take it away, Eli.
Yes, thank you for being sure. That was very, very beeful of you. Yeah, I don't know what that adjective means, but I feel like bees are very diligent. So you're
Yeah,
having
that's
the
a good
mindset
one.
of a bee. Yeah. Okay, on to grades 5 and 6. Question number 10. A bookshelf with 3 shelves has 17 books on the top shelf. Okay, 15 on the middle shelf and 7 on the obstructed bottom shelf here. Monica wants each shelf to have the same number of books. Okay. She also wants to move as few books as possible. How many books should she move from the middle shelf to the bottom shelf? Ooh, this is an interesting like optimization problem. Uh, so yeah, I mean, the way I'm thinking of doing it is like sort of a greedy algorithm type of thing. Like kind of just move as many books as we can and then move more. Like for example, we should always be moving from like the biggest to the smallest. So like if we move from the 17 to the 7, that would probably make sense. So like we move 1, we move 2, and then we would move another one and then move this one. I think that is definitely optimal because if you had any other way of doing it, like you would just be exacerbating your situation. If you like say moved one from here first, you'd have to replace that. So there's no reason why not just go from the one with the most books to the one with the least books at every step. And so I don't know if that's a proof, but I think it's good enough to do this problem. And I think we just want to figure out, like, if we go through this algorithm, how many books do we end up moving from the middle shelf to the bottom shelf? Okay, so let's get more space on the board here. So we start with 17, 15, and 7, right? So first we're going to move 2 books down from here. So let's see, we're left with 15, 15, and 9. And then we'll just keep on like moving 1 from here, 1 from here, 1 from here, 1 from here. And actually, I think that'll work perfectly if we do that twice. So if we move 2 from here and 2 from here, that'll leave this with 13, and each of these with 13. And so we'll have 13, 13, and 13, and then we'll be happy. And well, you can kind of just see we went from 15 to 13, and so we moved 2 books from this middle shelf. And so if we go up to our answer choices, it looks like we only needed to move 2 books from the middle shelf to the bottom shelf. And I think that's option B, although the chat seems very conflicted. Someone's even saying it's not A, B, and not C. So I don't know. I mean, maybe my reasoning is faulty. I don't know. We'll find out in a second. It is. Oh, well, no, not that it's faulty, but it's the right answer. It is B again. So it's always B. Yeah, B or 2. It's B2. Just like the previous one, it's also B. So it's B2. Great. Okay, back to you, Cynthia.
Yeah, maybe that old like wisdom of if you're not sure about an answer in a multiple choice test, just pick B. Maybe that's correct. It seems like a lot of these are B. Um, so Vera has built a tower of blocks. She wants to replace the 2 blocks with the question marks with 2 blocks with numbers. So we have these 2 right here. She wants the number on each block in her tower to be at least 2 more than the number on the block below it. In how many ways can Vera do this? Okay, let's start off by just thinking about the extreme cases, because then we know a limit and we can narrow down our possibilities. So I see that the one here, the one right below the last question mark is 6, which means the one right above this has to be at least 8. So I'm just going to put greater than or equal to 8, right? Because this has to be at least 2 more than the block below it. And then up here, our top block has 14 on it. And the one right below that has to be at least 2, or I guess, at least 2 away from, or yeah, at least 2 away from that, exactly. Which means that this has to be less than or equal to 12. So now that we have these boundaries, let's just do some casework, starting with if the first question mark is 8. Now, if that's 8, then the possibilities for the second question mark are we have 12, we have 11, and we have 10. And then if we go to 9, that won't work because 9 and 8 are only 1 apart from each other, right? Okay, now let's go to our next case, which is if the first question mark is equal to 9. And that means that our second question mark has the possibility of being 12 still and 11, but not 10 anymore, because if we have 9 and 10, that's less than 2 away. And our final case, or at least I think it is, is when the first question mark equals 10. And that means that our second question mark can only equal 12, right? Because if our second question mark were 10 or 11, then that would conflict with the one below it. So let's just count up the different cases. We have this first pair, 12, 11, 10, and then the next row, 12 and 11, and then the last possibility is another 12 with the 10. So that gives us 6 different cases, and that corresponds to answer choice D. It's not B this time, I guess. And I see some people putting D in the chat, although maybe a little bit less sure about that one, so we should probably check our answer. And it is answer choice D, 6. Okay, Eli, your turn.
Yes, thank you, Cynthia. And great job figuring out who was on first and who was on second. And I should say, who's on first, what's on second. And if you don't get that reference, you should go look up who's on first. It's a good comedy skit. Okay, on to question number 14 from grades 5 and 6. We have some shapes, and we want to know which shape or any rotation of the shape cannot be placed into the black parts of this large square. And by black parts, it means the background color. So like my hand color is what it means, or the wall color. Okay, so I think we can kind of just go through one by one. For A, well, I mean, I don't even have to rotate it. It just fits in right here. So I think that fits. You can just get rid of that option. Let's see, for B, that one's a more interesting shape. Let's see, do I see any of those in the diagram? Ah, it's sneaky. It's actually upside down. But if you see, there's that shape right there, which is the same as the shape from B. So we can get rid of that one. For C, we just need to find like this weird squiggly thing. So, do I see any squiggles? Uh, let's see. Squiggles. Oh, is this also hidden? Let's see. Just thinking here, but that's not quite right. I know that this should exist. Uh, Squiggle. Let's see. Here. No, it's like part of one. Maybe it's in the other direction. Can chat help me out here? Everyone's saying D. Yeah, I can kind of tell that D definitely can't fit. Okay, we'll get to that. But I think C should be possible. So what am I missing? Like, like where? Oh, is it right there? Uh, oh yeah, it's right there. Oh my God. Why is that so hard to see? There it is. Okay, there's the squiggle. Okay, we found it. C is wrong. On to D. Yeah, I mean, just look at the diagram. There's no way we're gonna get one of those happening in there. But like we can go around and check to be sure. You can imagine like placing this on the diagram and trying to move it around. Yeah, this is just too big. We don't get any of those shapes in here. You can try rotating it as well. But yeah, I just don't see where this appears. Just to make sure we can go on to E and see if we can find E in here. Maybe this one's easier. Okay, yes, I found this one. This is E right here. You see that's going in, out, and in. That's just a rotation of E. So good, we found E, and we're confident that D is the right answer. Okay. Yes, I know E is easy to find. I found it. It's just C. C, I can't see C. What is the problem with C? I don't know. But let's see. Is D the correct answer? Yeah, it is. Cool. On to you, Cynthia.
All right, nice job. I know that was like kind of hard to find. I was searching for them too. So I think this might be our last one. How time flies when we're having fun. Jessica cuts four identical squares from the corners of a square sheet of paper as shown. The total area she cut off is 16 centimeters squared, and the area of the cross that remains is 9 centimeters squared. What is the perimeter of the cross in centimeters? Okay, so this is a geometry-ish one. She cuts off 16 centimeters squared, and the part that she cuts off is like four identical squares. So each of those squares should have area 16 divided by 4, which is 4, right? And that reminds me of a square that has area 4, and that means that it has side lengths 2 and 2, right? Each of these is 2. I will write all of them for the sake of our diagram. And then we know that the area of the cross that remains is 9 centimeters squared. So let's let this part that we don't know right here be x. And this cross should have width x, and the length will be 4 plus x, right? Because we have this segment up here, that's 2. This middle part is x, and then the bottom part is 2 as well. So x times 4 plus x. And then we have the other two sides, which are just x times 2 and x times 2. So we're adding 4x. And that, as we're given in the problem, equals 9. So let's just solve and do some algebra. X squared plus 4x plus 4x, so x squared plus 8x equals 9. X squared plus 8x minus 9 equals 0. And we've got this quadratic right here. And I see that I can factor this pretty easily into x minus 1 times x plus 9. And if you don't believe that this is right, you can try and multiply it out and just verify that we have our quadratic from earlier. But I'm gonna trust myself on this one. And this means that x either equals 1 or negative 9. Does either of these seem suspicious? I feel like negative 9 seems suspicious, right? Because can we have a side length of negative 9? The answer is we can't. So x equals 1, and that means that the perimeter will be 1 right here, And then each of these, there are eight of these side length two ones, part of the perimeter, right? So we'll do two times eight, and then plus how many of these side length one ones do we have? One, two, three, four. We have four of those, so one times four, and that gives us 16 plus four, which is 20. And that looks like answer choice C to me. And very nice job to everyone who got C. This one is kind of a doozy. And yep, the answer is C. Awesome. Yeah,
All right.
I think that's it for today. Thanks for sticking with us, and hopefully you guys had fun.
Yes, I'll spotlight both of us so we can give a send off together. Yeah, thanks for coming. I think this is the end of our live solve. I know we're ending a bit early, but like we got through all the problems. So yeah, thanks for coming, and hope you enjoyed it. Uh,
Bye, everyone.
yeah, we can just hang around. I don't know if the live stream's still happening. If it is, I live stream. Hmm. So should probably talk about something interesting while we're just like here. So let's see, different icebreaker. How about is a hot dog a sandwich?
This one is controversial. Oh my goodness. Yeah, Eli, what's your take on this?
Well, okay, almost everyone says a hot dog is not a sandwich. And so I like to just advocate for the hot dog sandwich lovers. And so I would say, like, think about the word sandwich in the English language, It means to sandwich something between two other things. It's like to have something else that's in between two other things. And that's true of a hot dog. It's like the two sides of the bun, and a hot dog is like sandwiched in between. So therefore, by the English language, a hot dog should be a sandwich. Just makes sense.
Okay, okay. I think that's a fair take. Um, yeah, I haven't given this much thought. I don't know. I'm gonna say it's not a sandwich because I love hot dogs and I'm not a huge fan of sandwiches. That might be a hot take. But just something about sandwiches, not a fan. So yeah, I'm just gonna go with if I like hot dogs and I don't like sandwiches, then they must be different.
That's an interesting point. Although, I mean, like to say you don't like all sandwiches is a stretch
I
because
know
like
this
do you
is
just do you like bread? Because I think you could have a nothing sandwich, and that's just like two pieces of bread. So if you don't like sandwiches, that means you don't like bread, you know?
maybe I just like one piece of bread, but I don't like two together.
Oh, okay. So one piece of bread is fine. What if you took one piece of bread, split it in half, and then made a sandwich out of it? It would still
No.
technically be one piece of bread, though.
Yeah, I guess that's technically true, although it's just something about the stacked bread that I don't like. But maybe if it's
Mm.
like stacked next to each other instead of stacked on top of each other, like it is in a hot dog, then I prefer that.
Okay, so horizontally stacked bread as an
Yes,
alternative
exactly.
sandwich. This is a
Exactly.
very interesting idea. I think you could make a business out of this. I think we should become partners and like make billions of dollars on our new
Yeah,
innovation in the sandwich
definitely.
industry. I think this could work.
Very
So,
true.
so okay, I'm just curious, like how you eat this. Like you have bread and
Just
then a
like how
bunch of
you eat
stuff
a
and
hot
bread.
dog, like sideways.
So you just twist your head and then eat it as if it was a sandwich.
Exactly.
Okay, so you're advertising to the people that really like twisting their head and like acting as if they've just been tilted 90 degrees. Yeah.
Yes,
Okay, I'm sure there's a lot of people out there that enjoy that experience. So yeah, this is going to be
definitely.
really popular, really popular. Yeah, because who wants to just keep their head vertical? Why not see the world from a
Yeah, why
different
not just like
perspective?
make things a little bit more difficult for yourself? Exactly. What
Hmm.
about the slightly less controversial take of is a hot dog a dog?
A dog? Like,
Yeah. I mean,
Um,
why would it be called hot dog if it weren't a dog?
that's an interesting point. I mean, linguistically, true. And I mean, in other languages, a hot dog is still called a hot dog. Like in Chinese, it's real go, and then like that's
Yeah.
literally just hot dog.
Whoa, that
Um,
do you learn do you take Chinese class?
yeah, I'm in a Chinese class right now, so it's going well. I can actually
That's really
probably,
impressive.
I don't know
Your
if I can write.
pronunciation is like spot on.
Okay, this is real. I don't know what. Oh, can you even see that? Oh, yeah, you can. Okay, and I don't know how to write go. It's like
It's like,
there's something like this, and then
right? Is it that?
oh, that's probably right.
My Chinese is rusty.
Okay, I'm gonna say that's right. And yeah, that's interesting. I mean, there's like a ball on the side, and then this is like the goal. Right. Okay.
Yeah.
Um, yeah. Okay, so there you go. This has also become a Chinese lesson. Honestly,
hmm
I think we're probably allowed to just leave, but I don't know. I've never finished one this early. And also, usually the way that it works is like we're in a separate Zoom. And so, like, once the scene has switched, so the live stream is not on anymore, like, no one can see us or hear us. But that's not the case anymore. So, honestly, I have no idea what we're doing. Uh, it's very possible that we should just leave now. I'll give it to 8:20 and then I say we call it quits then. Yeah. Okay.
Yeah.
I see some other interesting things here. The opposite of a hot dog is a chili dog. Wouldn't the opposite of a hot dog be a cold dog or a cold cat?
That's so true. Oh, I see we're getting the six sevens now. I was wondering, I was hoping that none of the answers would like involve six and seven. Then maybe we could have avoided it, but
I mean, you got close. One of your answers was six, right? And then the
oh
answer
yeah.
below it was seven. So you could have said, is it six or seven?
Yeah. I'm glad I avoided that. But we can't escape it. Six, seven, six, seven, six, seven, six, seven. Yeah.
67 pounds of egg fried rice, or egg fired, I should say. This egg has been fired from the job. Uh, okay, well, I think this has been a successful live solve, and thanks to everyone who stuck around for hearing us talk about other things
Yep.
that are also things. But I think we can call it quits. So I at least will be going now, and okay, I
Yep.
hear music, and I feel like music is a good cue. So thanks everyone. Bye.
Yeah. Thanks, everyone. Hopefully you had fun both doing math and also discussing hot dogs. Bye.